Who does better when looking at average test scores? Small schools or large ones? At first thought, it seems that small schools would win every time. There are certainly arguments to support this. For example, a smaller school might have a lower student-to-teacher ratio. However, could it be possible that the smaller school's average test score looking better than a larger school is just a statistical artifact? Remember that the initial observation is based on an average measurement. As soon as we compute averages, we are dealing with statistical objects. These have properties that can affect their interpretation. This mini video talks about the underlying statistical mechanism at play here, which may create the idea that the average of a small sample versus the average of a large sample represents something fundamentally different. We argue that this difference can actually be attributed to the difference in sample size. That smaller samples from an average test score population vary a lot more than larger samples from the same average test score population. Recall in a previous video that we assume that underlying all measurable phenomena are random variables, and that these random variables are taken from a distribution, i.e., a function that tells us with what probability values occur. In this case, average test scores comes from some grade distribution that determines all average test scores in the universe. Observed average test scores are realizations of average test scores from this population. Statistics shows us how to use these realizations, aka samples, to make inferences about the population. In this example, we compute the average test scores across students drawn from 1,000 large schools, and then the average score from students from 1,000 small schools. We compare these averages and see that the small school averages are higher. The question is whether this is a robust finding. We believe that all the data is coming from random samples from the same population. Let's convince ourselves of this in a more concrete way. Here are the steps we take. Using Python, we simulate an array of test scores that are large sample sized, say a school size of 1,000 students. We do the simulation 1,000 times. We then simulate an array of test scores that are small sample sized, which might only be 10 students per school. This is also done 1,000 times. We then compute the averages, specifically the means of each sample. So you'll have 1,000 means for the small school samples and 1,000 means for the larger ones. Drawing a plot of each group of means that we have, we see the two sample distributions. Looking at them together, we can see that the small school distribution of test scores has a far larger variance, or spread. This means that a small school average test score can be very high when compared to a large school, even though they've both come from the same underlying distribution, with no systematic difference in average test scores. It's worth bearing this possibility in mind when reading news and reports on the characteristics of small sample statistics versus large ones. More generally as well, it's useful to think of how sample size can affect many different properties of statistics beyond the variance. We're Micro Insights. Thank you for watching this video.